Hello, good morning, welcome, and welcome back. This is again SNT 2021 for the last day of the SNT. So to start this day with an invited talk after two round tables, we will have an invited talk on risk mitigation that will be given by Philippe Perret from Météo France, which is the VAAC managers of VAAC Toulouse, the Volcanic Ash Advisory Center of Toulouse, and he will be presenting on his work and on behalf of a group of an international consortium with the World Meteorological Organization, partner from the civil aviation authorities and risk mitigation community, as well as infrasound researchers across Europe, on the use of infrasound data for early notification of volcanic ash. And since we have quite a short time, I will not make it long, and I will defer to Philippe to present now. So Philippe, thank you very much for accepting this invitation, and thank you very much for giving this talk today. Please, you have the floor.
Thank you, Pierrick. I'm going to share my screen. Oops. Just a moment.
It's coming up.
Okay, can you see my screen?
Yes, we see the screen.
Okay.
And yeah, that's correct. Thank you.
Okay. Thank you, Pierrick. Thank you for this kind invitation to present this work on this use of infrasound data for early notification of volcanic ash, carried out with my colleagues listed on the slide and with Larry Mastin from the US Geological Survey. So I'm trying to go to the, okay, next slide. So the story of volcanic ash and aviation started in the 1980s when numerous incidents due to ash encounters were reported. Firstly, in 1982, a Boeing aircraft flew over the Galunggung volcano in Indonesia. The four engines of the aircraft stalled and the aircraft lost 25,000 feet in 15 minutes. Fortunately, engines restarted and the aircraft landed at Jakarta. A few weeks later, another aircraft was forced to land after ash encounters, and lots of incidents due to volcanic ash were reported in the 80s. Then, since 1982, volcanic ash has become a real concern for the International Civil Aviation Organization. Volcanic ash is a natural hazard for aviation affecting safety and performances. Because ash particles are very hard and abrasive, they can cause damage to engines, possibly leading to engine failures. They may also cause long-term damages by eroding some engine pieces. Because of the melting point very close from engine temperature, volcanic ash particles may melt and form glassy coating in the turbines. Opacification or windscreen is another danger associated with volcanic ash. According to statistics, more than 5,000 volcanic ash advisories are issued every year. Airspace is contaminated by volcanic ash 20 days a year, with ash reaching up to flight level 300, which is about 9,000 meters height. Damage cost has been estimated to more than $250 million. Avoidance cost has been estimated to many millions of dollars. But fortunately, no victims have been reported so far from ash aircraft encounters. To address this issue of volcanic ash, the International Civil Aviation Organization has decided to set up the International Airways Volcano Watch in 1987 with the support of the World Meteorological Organization. And so 9 volcanic ash advisories have been designed by ICAO with the following duties: watch volcanic ash 7 days a week and 24-hour a days, and issue volcanic ash advisories on aeronautical dedicated communication networks. On this slide, on the left-hand side, you can see a map which displays the distribution of the 9 volcanic ash advisory centers. And as you can see, the Toulouse VAAC is in charge of a very vast area, including Africa and a large part of Europe. Within the International Civil Aviation Organization, meteorological topics are addressed into a specific commission called the Met Panel. In this commission, 2 working groups deal with volcanic ash, the Information and Service Development Group, and on the other side, the Operations Group. On the other side, the World Meteorological Organization deals with the best practices for the volcanic ash advisory centers. And the WMO defines standards for VAAC forecasters, skills and competency, but also promotes the sharing of experience and methods between the VAACs, uses scientific progress for improving observation and transport prediction of volcanic ash, strengthens links between volcano observatories and VAAC communities, and finally contributes to volcanic ash product evolution, for instance, quantitative products. So in this organization, the Toulouse VAAC is a piece of the International Airways Volcano Watch. VAAC Toulouse is hosted by Météo France in Toulouse, and there is 1 forecaster on duty 7 days a week, 24 hours a day, exerting a watch on the volcanic ash activity. And so this year, 250 volcanic ash advisory have been issued so far, and mostly for the Etna volcano in Italy and for the Stromboli. But we have also issued some volcanic ash advisory for the Nyiragongo volcano in the Congo Democratic Republic. So this is a quite active volcanic year in the VAAC Toulouse area of responsibility. On the left-hand side of this slide, you can see a snapshot of the VAAC Toulouse web portal, where you can find further information on eruptions and on our volcanic ash activity. So here is a link to browse this web portal. How to detect the presence of volcanic ash in the atmosphere? Well, several systems are available. It's possible to use observation from state volcano observatory using on-site monitoring, for instance, webcams, seismic sensors, radars. For instance, the Italian Institute of Geophysics and Volcanology issues volcano observatory notice for aviation called VAAC. It's a specific advisory. And they issue this kind of advisory for the Etna volcano. It's also possible to use satellite remote sensing, for instance, imagery from geostationary or low polar orbiting satellites. Pilots can also report the presence of volcanic ash in the atmosphere. It's also possible to use measurement from aerosol lidars from ground or from satellite. The use of the measurement of sulfur dioxide can be a possibility also to use it as a proxy for volcanic ash, and this is the way followed by the VAACS systems. Instrumented aircrafts can be used during field campaigns to measure the concentration of volcanic ash in the atmosphere. And finally, it's also possible to use other observing system or diagnosis, like for instance, the Earthwalk platform run by the Institut de Physique du Globe de Clermont-Ferrand. The prediction of the ash transport for the next hour remains a challenge. And for that, the VAACS run sophisticated numerical dispersion models to predict the transport of volcanic ash in the atmosphere for the next 18 hours. These models use physical processes using wet deposition, sedimentation, turbulent mixing, but also coupling with numerical weather prediction models and sophisticated source terms for the description of the plume shape, of the top of the clouds, of the emission rate of the volcano. The model outputs are the forecast of ash concentration charts for the next 18 hours. Here is given an example for the Toulouse VAAC with the Mocage accident dispersion model. Here you can see a typical concentration charts providing the concentration at 3 different layers, 3 different levels on the area. It was provided for a specific exercise with an SOS volcano called Furnace Volcano. And there is a trend for this product to go towards quantitative products, as it is a request from the International Civil Aviation Organization. But you must know that given the source term uncertainty, the uncertainty is the initial conditions, every additional observation is worthwhile for the VAACs. Timeliness is a real concern for the VAACs. Some timeliness criteria called Key Performance Indexes, or KPI, have been defined by the ICAO for Volcanic Ash Advisory. And so, according to this criteria, the first Volcanic Ash Advisory shall be issued within 20 minutes after the confirmation of ash evidence in the atmosphere. The second Volcanic Ash Advisory shall be issued within 55 minutes after the first advisory. These criteria, these KPI, are generally met for monitored volcano. Volcano Observatory issue VONA, so specific advisory, and the VAACS issue the first Volcanic Ash Advisory within 20 minutes. But the concern is that for poorly monitored regions, the VONA, the advisory, is often missing, and the detection relies on satellite imagery when available due to cloud cover limitation. And in that case, sometimes the issuance of the VAAC advisory is delayed. And in that way, the infrasound detection has appeared as an additional means to collect timely data on eruptions. So since 2010, there is a continuous interest of ICAO and WMO for the use of infrasound detection for the VAAC notification. And there was an official action in 2020, which was tasked to the VAAC Toulouse by ICAO to lead a working group on the use of infrasound data in support of the International Airways Volcano Watch. And this action consists in posturing in collaboration with CTBTO and the Airways, Atmospheric Dynamics Research Infrastructure in Europe, so European project, with the Airways community, the further development and testing of the Volcanic Information System, VAAC, with the objective to establish a real-time operational system for use by all VAACs, and to report the results of the system back to the next meeting of the working group ICAO. So for the development of this Volcanic Information System, VAAC, the synergy between CTBTO and the Airways community has offered a unique opportunity for the VAAC establishment using infrasound data from a global station network. Airways advanced products provide valuable parametric inputs on the atmosphere dynamics that drives infrasound wave propagation. CTBTO brings its operational infrastructure to support dissemination of information to VAACs through the VAAC prototype deployed with Airways 2. And the proposed approach has been tested with VAAC Toulouse, mandated by the ICAO to demonstrate the usefulness of infrasonic data to International Airways Volcano Watch. A prototype system, VDEC, has been developed within the RISE 2 project in 2018. You can report to the paper by Le Pichon et al. In 2019 and to the e-poster presented in this meeting. So the idea is to use an international monitoring system operated by CTBTO, the IMS network, to notify the VAAC. So here is a display of the distribution of the IMS infrasound arrays and Volcano, represented here on these maps by triangles. And the triangles represent volcanoes that had activities during the last 10,000 years. For each volcano, the distance to the nearest IMS infrasound station is color-coded. And this IMS network offers the advantage to have a multi-year continuous quality recordings, but also to present a global coverage with a median distance from any volcano to the nearest IMS infrasound array less than 1,000 kilometers. So we have a mean travel time of 55 minutes, assuming an isotropic propagation with a celerity of 300 meters per second. The VAAC system has been assessed on a set of historical data, and the results were presented at the last ICAO and WMO meetings in 2019. And the VAAC system has been assessed on a set of eruptions across the world for a set of different volcanoes. And the results have shown that the VAAC system was able to detect all the major eruptions with the volcano explosive index greater than 3, associated with the volcanic ash advisories. The systematic comparison with the UNIFI early warning results on the period from 2008 to 2016 have showed that the most significant episodes of lava fountaining and ash eruption are well identified. For smaller events, the system performances highly depend on favorable propagation conditions. So now let me present two recent case studies. The first case study is La Soufrière dramatic eruption, which occurred on the 9th of April of this year. And for this eruption, there was an ash plume which rose up to 10 kilometers with a series of puffs in the days after. And 2,000 residents had to be evacuated. The volcanic ash advisory was issued by the Washington Volcanic Ash Advisory Center at 13 Zulu and 45 past 13 Zulu. And here is an example of this volcanic ash advisory. So here you can follow the position of the volcanic ash cloud at the initial time here, so near the island, and the prediction of propagation for the next 18 hours provided by the Washington VAAC. For that specific eruption, the signal was detected by the IMS network and especially by the Guadeloupe sensor, so 300 kilometer distance from the volcano. And this detection was mentioned on the social network by CTBTO. There was a tweet from CTBTO reporting for this detection. Here you can see on the left-hand side on the slide. And the signal was treated so as to build an infrasound parameter, which is a combination of eruption persistency and magnitude, corrected from propagation effects so as to reduce false alarms. And here on this graph, you can follow the progression of the signal across time, here from the 9th of April to the 12th of April. And you can follow the signal across the time here with the identification of the series of PUB. Here you've got the VAAC notification indicated by the red line here, red vertical line here, and by the arrow. So in that case, the VAAC notification would have been issued to the VAACS at around 13 Zulu of April 9th, so timely with the second volcanic ash advisory. In addition, it is possible to follow from the VAAC sequence the reconstruction of the chronology of the eruption, and the idea here is to provide some information for the source term for the dispersion models, that is to say, to provide some information on the initial conditions of the eruptions, which is a very important information to predict the future dispersion, future transport of the volcanic ash cloud. And now I would like to present you a comparison between satellite imagery from the GOES Ash composite satellite provided by the NOAA versus infrasound detection at the Guadeloupe infrasound sensor provided by CTBTO. And these results were kindly provided by our colleague from CTBTO, IPGP, KNMI, and LOA ICAO Institute. This is a comparison between the two signals on the period from the 9th of April to the 14th of April for this eruption. So let's run the video. Here the volcanic ash is indicated by the red color here on the satellite imagery, and here you can follow the puff on the infrasound signal. And as you can see, the comparison show a good correlation between infrasound signal and satellite data. And also, the infrasound detection provide realistic description of the time sequence of the puffs which are easily followable on this here on this diagram. So very interesting results for this eruption. The second case study is a Nyiragongo dramatic eruption, which occurred in the Democratic Republic of the Congo, the 22nd of May 2021. Around 1630, the Nyiragongo volcano erupted with significant ash emission. 30 people were killed by lava flows and gases. There was a high street on the Goma city, and the evacuation order was given in the following days. As the Nyiragongo is a poorly monitored volcano, the Toulouse VAAC was informed on the May 22nd, but in the late evening at around 20:30. So the first volcanic ash advisory was issued at around 21 Zulu, so more than 4 hours after the eruption starts. And in that case, we received no VONA after the eruption, immediately after the eruption. It was only the day after. And so we have to rely on satellite imagery for the prediction of the volcanic ash transport. So here is an example of satellite observation which were used for describing the initial condition in the volcanic ash advisory and for checking also the volcanic ash model predictions. Here is a volcanic ash, the second volcanic ash advisory, which was issued by the Toulouse VAAC for this eruption. And so here you have the position of the volcanic ash cloud with some indication on the bottom of the cloud and on the top of the cloud, and the prediction for the next 18 hours of the transport of the volcanic ash cloud. For this eruption, there was also a detection by the CTBTO network with a detection by the sensor located in Kenya, 800 kilometers from the Nyiragongo volcano, and this detection was reported on the social network by CTBTO, as indicated here on the left-hand side of the slide. As we did for the last eruption of La Soufrière, we plotted the signal, the infrasound signal across time for this eruption, and we plotted the VAAC notification linked to the IP parameters. And here, this notification is also plotted in red. And as it can be seen, by applying standard parameters, the VAAC notification would have been issued at around 18 Zulu on the May 22nd. So in addition, VAAC provides time information on eruption kinetic, the PUFs, which is a very valuable source term information for the dispersion models. So as a conclusion of this presentation, scientific collaboration on VAAC is an asset for CTBTO and ICAO WMO communities. Infrasound technology has demonstrated its maturity in possibly providing timely notification. It allows to draw the attention of the VAAC forecasters on the occurrence of an eruptive event. It allows also to reconstruct the time sequence of the eruption, providing some information on the source term for dispersion models. The results are promising, especially in the case of major eruption and for poorly monitored regions. The future works. The plans are to improve the reliability of the notification results in order to reduce the false alarm rate. Further evaluation of the VAAC system is required, with a possible extension to other VAACs with poorly monitored volcanoes in the area of responsibility. A proposal is also to calculate the source amplitude from long-range infrasound measurements to estimate the occurrence and possibly the height of the ash plume, which is a key parameter for ash dispersion models. Another plan is to integrate data from regional infrasound array to lower the response time and to improve the reliability. And finally, we would like to evolve from data reanalysis tool to near real-time alert system by using the real-time data. And for that, it's really important to have a collaboration on infrasound detection, which should be strengthened between CTBTO, the International Civil Aviation Organization, and the World Meteorological Organization. So thanks a lot for your attention. I'm open for any question. Thank you.
Thank you very much, Philippe. That was a very, very interesting talk. I'm very glad that you could give it to us. And it opens a lot of questions, of course, and I'm sure there will be some coming later to us that we will address to you. Being told that we have to close now because we have to go to the next meeting. So you just made it on time. Thank you very much for respecting this. But for the viewers, we had over 120 viewers, and I invite them to send us questions if you have any, and we'll send them to Philippe and post them on the portal very shortly. So thank you again, Philippe. We'll be closing now. That was very nice to have you, and have a good day. And I hope to see you soon again. Thank you.
Thanks a lot. Have a good day.